Hello friends, welcome to HP Vibrant Academy. In the last lecture, we have started the discussion on the properties of the permutation. So in the last lecture, we have discussed part 1. So in this particular lecture, we will discuss about the part 2 on the properties of the permutation. So let's start our discussion. So the first topic is cycle decomposition. Okay. So in the previous set of lectures, we have discussed that a permutation that belongs to a symmetric group can be represented. Permutation can be represented either in array form or in the cycle form. Okay, so let us take an example of permutation in a array form. Okay, so we have sigma is equal to, this is in the first row we have 1 2 3 4 5 6 7 8 9, and in the second row we have 3 4 2 1 6 5 8 7 and 9. Okay, so these are the symbols, and these symbols are mapped to second row. Okay, in the first row we have the symbols, and in the second row is where they are mapped. Okay, so 1 is mapped to 3, 2 is mapped to 4, 3 is mapped to 2, 1 is mapped, 4 is mapped to 1, 5 is mapped to 6, like this. Okay, so let us write down in the cycle form. Okay, so clearly 1 goes to 3, so sigma is equal to, let us start from here. So we have 1 goes to 3, 1 goes to 3, now 3 goes to 2, 3 goes to 2, now 2 goes to 4, 2 goes to 4, now we have 4 goes to 1, so cycle is getting repeated. 4 goes to 1, so this is closed. Now we have 1 2 3 4 is done. Now we have the element, next element is 5, so let us start from 5. 5 goes to 6, 5 goes to 6, and 6 goes to 5, 5 goes to 6, and 6 goes to 5, so this is closed. Now we have the next element as 7. Now we have 7 goes to 8, and 8 goes to 7, closed. Now we have 9, 9 goes to 9. So these are the disjoint cycle. Okay, so this sigma, that is permutation, is decomposed into disjoint cycles, and this process is known as cycle decomposition. Cycle decomposition. By cycle decomposition, we presume that the decomposition is done into disjoint cycles, and disjoint cycles are those cycles in which there are the elements are not in common. Okay, so let us read this. A cycle decomposition of a permutation expresses it as a product of disjoint cycle. So these are the product of disjoint cycle. This means the permutation is broken down into a smaller cycle that has no elements in common. So elements are not in common between these cycles. Each cycle represents a circular arrangement of elements where each element maps to the next and the last element maps to the first. So let us take this cycle 1 3 2 4. This means each cycle represents a circular arrangement element where each element maps to the next. So this element maps to next, 3 maps to next, that is 2, 2 maps to 4. So 1 maps to 3, 3 maps to 2, 2 maps to 4, and 4 maps to 1. So this is nothing but a 4 cycle. Okay, because 4 elements are there. So this is known as 4 cycle. Okay, similarly 5 6. 5 6, this means 5 goes to 6, 6 goes to 5. This is nothing but a 2 cycle. And 9 is 1 cycle, because 9 goes to 9 and 9 goes to 9. Okay, every element of Sn has a cycle decomposition. So Sn के जितने elements होंगे सबका cycle decomposition होगा. दूसरा, in a cycle decomposition of element of Sn, cycle can appear in any order. So उसको किसी भी order में लिखा जा सकता है, like this. So we have sigma is equal to 1 3 2 4 5 6 7 8 and 9. This we can write is any order. Sigma is equal to 1 3 2 4. This is 7 8. This is 5 6. This is 9. Sigma we can write as 1 3 2 4. This is 9 5 6 or 7 8. Okay, so cycles can be written in any order. Okay, this is known as cycle decomposition. Now we have the next topic is Sn is not abelian if n is greater than equal to 3. तो एबिलियन ग्रुप क्या होता है? एबिलियन ग्रुप, इफ द elements of group satisfy the commutative property, then we call that group as abelian. ओके, तो इसका मतलब S1 क्या होगा? एबिलियन होगा, बिल्कुल होगा. एज पर दिस स्टेटमेंट, इफ n इज ग्रेटर देन इक्वल टू 3, मतलब if n is greater than equal to 3, then Sn is not abelian. Okay, this means n is greater than equal to 1 and less than 3, then Sn is abelian. ओके, तो S1 abelian होगा, S2 abelian होगा, बिल्कुल होगा. S3 is not abelian, S4 is not abelian. Similarly, Sn is not abelian और n greater than equal to 3. समझ में आ रहा? तो 3 और 3 से ज़्यादा अगर n की वैल्यू है तो वो abelian नहीं होगा. तो लेट अस शो दिस. So we have S1 is equal to all those bijections from a single S1 is a सिमेट्रिक ग्रुप इनटू वन लेटर, मतलब वन पे सिंगल मैपिंग हो रहा है. ठीक है, 1 goes to 1 and it forms a group under operation composition of function. So 1 is being mapped to 1. This is clearly an identity. This means S1 is equal to single element, that is singleton E. मतलब S1 में सिर्फ एक ही एलिमेंट होगा, that is identity. एक ही एलिमेंट है तो क्या होगा? S1 abelian होगा, बिकॉज ऑब्वियस है कि एक ही एलिमेंट है तो कम्यूटेटिव प्रॉपर्टी तो सेटिस्फाई होगा ही. लेट अस वेरीफाई दिस फॉर S2. S2 इज इक्वल टू, S2 में कैसे एलिमेंट्स होंगे? ऐसे एलिमेंट्स होंगे कंटेंट्स ऑफ ऑल द बाइजेक्शंस फ्रॉम ए टू लेटर, मतलब टू एलिमेंट सेट, तो 1 और 2 एलिमेंट होगा एंड मैपिंग इज टू 1 and 2 सच दैट दिस फॉर्म्स ए ग्रुप अंडर ऑपरेशन कंपोजिशन ऑफ फंक्शन. तो 1 और 2 का मैपिंग कहाँ पे हो रहा है? 1 और 2 पे. ठीक है, तो लेट अस डू द मैपिंग. तो कितने नंबर ऑफ मैपिंग होंगे? 2 फैक्टोरियल, मतलब 2 मैपिंग होगा. So let us take the mapping. So this is, let us name this as f. So this is 1 goes to 1, 2 goes to 2, and second one is 1 2 1 2, 1 goes to 2 and 2 goes to 1. So this is our identity mapping and this is, let us name this as f. So S2 is equal to, first one क्या होगा? identity हो गया. second क्या होगा? 1 goes to 2 and 2 goes to 1. this is close. तो E होगा और 1 2 होगा. तो S2 में क्या होगा? दो एलिमेंट होगा ना, एक आइडेंटिटी होगा और दूसरा 1 2 होगा. So identity times of 1 2 is equal to 1 2 times of identity. Okay, so clearly this is satisfying the commutative property. Therefore S2 is abelian. S2 abelian हो रहा है. ठीक है, now let us find this for S3. S3 contains all the bijections from a 3 element set, 1 2 3 to a 3 element set, that forms a group under operation composition of function. Let us find the elements of S3. So we have the bijections. So we have 1 2 3. So we have 3 factorial number of bijection. This means 6 bijections are there. Okay, six number of bijections will be there in S3. Let us do the mapping. So the first one is identity. 1 goes to 1, 2 goes to 2, 3 goes to 3. Let us take 1 goes to 1 as, and 2 goes to 3, 3 goes to 2. Now here let us take 2 goes to 2, 1 goes to 3, 3 goes to 1. Now we have 3 goes to 3, 1 goes to 2, 2 goes to 1. Now let us take like this, 3 goes to 1, 2 goes to 3 and 1 goes to 2. Now we have 2 goes to 1, 1 goes to 3 and 3 goes to 2. So this is nothing but identity element. This is equal to 1 goes to 1 and 2 goes to 3, 2 goes to 3 and 3 goes to 2. This is closed. Now this one is 1 goes to 3, 3 goes to 1. This is closed. Now we have 2 goes to 2. Now this is 1 goes to 2, 1 goes to 2, 2 goes to 1. This is closed, and 3 goes to 3. Now this is 1 goes to 2, 2 goes to 3 and 3 goes to 1. This is closed. Now here 1 goes to 3, 3 goes to 2 and 2 goes to 1. So we have the elements as, let us write down the elements of S3. So the elements of S3 is, first one is identity element. The one is single mapping. 1 goes to 1 is identity. So this is 2 3. Identity times of 2 3. So this is 2 3. Now we have 2 3 times of 2. Okay, so mathematicians do not prefer to write the single mapping. Okay, 2 goes to 2. One element. This is element of cycle of length 1. Okay, this is 2 is cycle of length 1. Okay, so mathematicians do not prefer to write cycle of length 1. Hence we ignore this. So this is nothing but 1 3, and this is 1 2, and this is 2 3. The elements are identity 2 3. This is 1 3. This is 1 2. This is 1 2 3. This is 1 3 2. Okay, total 6 elements are there. Okay, now let us take two of the elements. Let us take this as 2 3 times of 1 3, and let us calculate 1 3 times of 2 3. So this is equal to, let us do the multiplication. So let us take the start from 1. Okay, so 1 goes to 3 and 1 goes to 3, 3 goes to 2. So this is 2. अब 2 कहाँ से जा रहा है, 2 का कहाँ पे जाएगा, 2 goes to 2 and 2 goes to 3. This is 3. Now we have 3 goes to 1 and 1 goes to 1. So this is closed. So this is 1 2 3. Now let us write down here. So we have, let us start from 1. So 1 goes to 1 and 1 goes to 3. Now we have 3 goes to 2 and 2 goes to 2. Now we have 2 goes to 3 and 3 goes to 1. This is closed. So 2 3 times of 1 3 is not equal to 1 3 times of 2 3. Okay, hence S3 is not abelian. S3 is not abelian. ठीक है, S3 is not abelian. So hence Sn is not abelian if n is greater than equal to 3. So we considered S1 and S2 are abelian. S3, S4, S of n greater than equal to 3 are not abelian. Okay. Okay, so now let us proceed further. So we have the concept of cycle. So this we have already discussed. So let us revise this. So cycle is an element which starts with an index and end with same index. Okay, so let us take a cycle like this: A1, A2, A3 up to AM. Okay, so M elements are there. M elements. This is nothing but a M cycle. Suppose we have 1 2 3 4. So 4 number of element. This is 4 cycle. Okay, so this is nothing but a permutation. So what does this permutation do? it sends 1 to a next element. Okay, so it sends 1 to 2. On applying sigma it sends 1 to 2. Again on applying sigma it sends 2 to 3. Again on applying sigma it sends 3 to 4, and again on applying sigma it sends 4 to 1. So cycle is element which starts with the index and end with same index. So 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes to 1. So this is a cycle. This is nothing but, so 4 elements are there. This is a 4 cycle. Okay, this is a 4 cycle. And this 4 is called length of the cycle. So here we have, suppose this m elements are there. So m cycle means this is a cycle of length m. Okay, let us take an example. So we have a sigma is equal to, let us take this as a alpha instead of sigma. Alpha is equal to, let us write down is in an array form. So 1 2 3 4 5 6. So this is 2 1 4 6 5 and 3. Let us write down in the cycle form. Okay, so here 1 goes to, alpha is equal to, alpha is equal to 1 goes to 2, 2 goes to 1. This is closed. Now we have 3 goes to 4, 3 goes to 4, 4 goes to 6, 3 goes to 4, 4 goes to 6, and 6 goes to 3. This is closed. Okay, and we have 5 goes to 5. So these are the cycles. Okay, so this 1 2, 1 2 is nothing but 2 cycle, and 2 cycle is also known as transposition. Now we have 3 4 6, 3 4 6. This is nothing but a 3 cycle, and 5. This is a 1 cycle. Okay, so this is a cycle of length 1. So mathematician do not prefer to write cycle of length 1, hence we ignore this. So this is nothing but 1 2 times of 3 4 6. Generally we do not write the cycle of length 1. Okay, so and 1 2 is also known as transposition. So 1 2 times of 3 4 6. This is the cycle notation of the permutation alpha. Okay, so the permutation alpha sends element to next element. Okay, so we have, suppose we have a cycle like this, a1 a2 a3 up to am. Okay, so an application of this permutation is nothing but 1 1 onto mapping. So a1, on application of this permutation sigma, it send it to a next element. So a1 goes to a2, similarly a2 goes to a3, like this. am m minus 1 goes to am, and am goes to a1. Okay, so on the application of sigma, it goes from first element to a second element to third element, like this. So this is nothing but a cycle. Now we have write down the cycle decomposition. Okay, so the first one is this this is sigma. So we have sigma is equal to 1 2 3 4 5. This is 2 3 4 5 and 1. Let us write down in the cycle form. So here let us start with 1. तो 1 कहाँ पे जा रहा है 2 पे, ठीक है. 1 जा रहा है 2 पे, 2 जा रहा है 3 पे, और 3 जा रहा है 4 पे, 4 जा रहा है 5 पे, और 5 जा रहा है 1 पे. तो 5 is again going to 1, 5 is again going to 1. So this is closed. Okay, so this is so how many elements are there? 5. So this is nothing but a 5 cycle. Okay, and this 5 is nothing but length of the cycle. So this is also known as cycle of length 5. Okay, now we have tau as, this is 1 2 3 4 5, and this is 1 3 4 3 and 5. So let us do the mapping. So 1 goes to 1, closed. Now we have 2 goes to 3, 2 goes to 3 and 3 goes to 4, 4 goes to, sorry, 2 goes to 3, 2 goes to 3 and 3 goes to 4, and we have 4 goes to 3. Sorry, here it is 2. Sorry, here it is 2. Okay. One, 2, 3, 4, 5, and it is 1, 3, 4, 2, and 5. So this is 1 goes to 1, 2 goes to 3, 3 goes to 4, and 4 goes to 2. This is closed, and we have 5 goes to 5. So this is equal to 2, 3, and 4. This is nothing but 3 cycle. Okay, so here 1 goes to 1, 2 goes to 3, 3 goes to 4, and 4 goes to 2. So this is closed. At last we have 4 goes to 2. Now we have 5 goes to 5. This is nothing but a 3 cycle. Disjoint cycles commute. Okay, suppose we have these are the permutations. Sigma and tau are the permutation that belongs to symmetry group with n letter. Okay, so suppose the elements of Sn are like this. So in Sn we have total n factorial numbers of elements. So the last one is f of n factorial. So n factorial number of elements are there, and sigma or tau are one of these elements. So if sigma and tau are disjoint, मतलब उसमें कोई भी elements common नहीं होगा, that is no entries are common, then sigma tau is equal to tau sigma. Okay, so suppose we have the two, this is sigma, let us take this as sigma and this as tau. Okay, so if we multiply this, this is tau. If we multiply this, then we have sigma tau is equal to tau sigma. This means commutative property is being satisfied. Okay, hence we can say that disjoint cycles commute. Now we have order of k cycle is k. Okay, so order of a permutation is the smallest positive integer n such that tau to the power n is equal to identity. Okay, let us understand this. So we have, let us take a permutation like this. Sigma is equal to, the elements are I1, I2, I3, Ik minus 1 and Ik. Okay, so on application of sigma on I1, it goes to I2. Again on applying sigma, it goes to I3, because it sends it to a next element. So on application of sigma, I1 goes to I2, I2 goes to I3, like this. And Ik minus 1 on application of sigma goes to Ik. Okay, and again on application of sigma on Ik, it goes to I1. Okay, so this means on applying I1, sorry, on applying sigma to the power k on I1, it goes to I1. On applying sigma to the power k on I2, it goes to I2. Okay, so this means sigma to the power k is equal to identity. This means k is order of sigma. K is order of sigma. Sigma to the power k is equal to identity. This means k is the order of sigma. And we have, if k is the smallest integer, as per definition of order, k is the smallest integer such that sigma to the power k is equal to identity, then k is order of sigma. Okay, तो I1 पे सिग्मा टू द पावर k अप्लाई करने पे क्या आ जाएगा, I1 आ जाएगा. Okay, so like this, sigma sigma, we are applying sigma on I1, then it goes to I2. On applying sigma on I2, it goes to I3, like this. On applying sigma on Ik minus 1, it goes to Ik. Okay, so if we apply sigma square on I1, then it goes to I3. And if we apply I1 and we have sigma k minus 1, then it goes to Ik. And one more application of sigma on this, one more application on sigma, ik goes to I1. So we have sigma k minus 1 plus sigma, then sigma to the power k, it goes to I1. So this means on application of sigma to the power k on I1, it goes to I1. So this means sigma to the power k is the identity, as simple as that. So sigma, so k is the order, this is written here. Okay, so sigma to the power k, sigma to the power k on I1, it goes I1, it goes to I1. On application of sigma to the power k on I2, k on I2, it goes to I2. Okay, so there k is the order of sigma. Okay, okay, so let us proceed further. So we have what is the order of product of disjoint cycle. Okay, so suppose we have a permutation as sigma, and we have decomposed into a this disjoint cycle, sigma 1, sigma 2, these are the disjoint cycle. And let us consider the length of these cycles as, suppose length of sigma 1 is m1, length of sigma 2 is m2, and length of sigma k is mk. तो सिग्मा का क्या ऑर्डर हो जाएगा, सिग्मा का जो ऑर्डर होगा वो एलसीएम ऑफ m1 m2 m3 mk हो जाएगा। समझ में आ रहा है? तो यहाँ पे क्या है, देखो सिग्मा को हमने डिकम्पोज किया है 30 साइकिल्स के फॉर्म में, तो ये क्या डिसजॉइंट साइकिल है। तो 1 3 2 4 इसका लेंथ क्या है, इसका लेंथ क्या है 4 है, 5 6 का लेंथ क्या है 2 है, 7 8 का लेंथ क्या है 2 है। तो इसका क्या हो जाएगा, सिग्मा का ऑर्डर क्या हो जाएगा, एलसीएम ऑफ 4 2 एंड 2, दिस इज इक्वल टू 4। समझ में आ रहा है? तो सिग्मा इसका ऑर्डर क्या हो जाएगा, 4 हो जाएगा। द प्रीपोजिशन डज नॉट अप्लाई इन केस ऑफ नॉन डिसजॉइंट साइकिल। अगर डिसजॉइंट साइकिल नहीं है, जैसे 1 2 और 1 2 3 डिसजॉइंट साइकिल नहीं है ना, तो ये एलसीएम वाला जो फंडा है ना वो अप्लाई नहीं होगा। समझ में आ रहा है? तो सिग्मा का ऑर्डर ऐसे मत लगा देना, दिस इज नॉट इक्वल टू एलसीएम ऑफ 2 और 3। समझ में आ रहा है? तो ये ऐसे आने पे 6 आएगा, सिग्मा का ऑर्डर 6 तो है नहीं ना, तो इसको क्या करेंगे, पहले डिसजॉइंट साइकिल के फॉर्म में कन्वर्ट करेंगे। तो लेट अस कन्वर्ट दिस। तो वी हैव, अभी देखो इसको मल्टीप्लाई करो, तो सिग्मा इज इक्वल टू 1 2 टाइम्स ऑफ 1 2 3। अब देखो मल्टीप्लाई करने पे क्या होगा, दिस इज 1, सो 1 गोज टू 2, 1 गोज टू 2 और 2 गोज टू 1। सॉरी ऐसे नहीं, इसको मल्टीप्लाई करने पे क्या होगा, सिग्मा इज इक्वल टू 1 2 टाइम्स ऑफ 1 2 3। लेट अस डू द मल्टीप्लिकेशन। सो स्टार्ट फ्रॉम 1, so 1 goes to 2 and 2 goes to 1, so this is closed. Now we have the second element is 2, so 2 goes to 3 or 3 goes to 3, ठीक है। तो 1 2 3 all elements are covered, so this is equal to 2 3, तो सिग्मा इज इक्वल टू 2 3। तो सिग्मा का ऑर्डर क्या हो जाएगा, 2 हो जाएगा। समझ में आ रहा है? तो एलसीएम वाला जो फंडा है ना वो डिसजॉइंट साइकिल के केस में ही होगा, अप्लाई होगा। समझ में आ रहा है? लेट अस प्रोसीड फर्दर। इनवर्स ऑफ ए परमुटेशन। ओके, सपोज वी हैव द परमुटेशन लाइक दिस, a1 a2 a3 am-1 am। इसका इन्वर्स क्या होगा, तो एलिमेंट्स को अपोजिट डायरेक्शन में लिख दो। तो वी हैव m1 am-1 लाइक दिस, a3 a2 a1। तो यहाँ पे देखो सिग्मा अल्फा इज इक्वल टू दिया, क्या दिया है 1 2 3, तो अल्फा इन्वर्स क्या होगा, अपोजिट डायरेक्शन में लिखना होगा 3 2 1। ओके, इसको ऐसे भी निकाल सकते हो। लेट अस मल्टीप्लाई दिस, 1 2 3 को मल्टीप्लिकेशन करो 3 2 1 से, क्या आएगा, आइडेंटिटी आना चाहिए। तो क्या आएगा, देखो यहाँ से 1 स्टार्ट फ्रॉम 1, तो यहाँ पे क्या हो रहा है, 1 गोज टू 3, 1 goes to 3 and 3 goes to 1, so this means 1 goes to 1, closed. Now we have, let us take the second element 2, 2 goes to 1 and 1 goes to 2, this is closed. Now we have 3, 3 goes to 2 और 2 goes to 3, this is closed। तो आइडेंटिटी आ गया ना, तो इसका मतलब क्या हो गया, ये अल्फ़ा है और ये क्या है, अल्फ़ा इन्वर्स है। ओके, सिमिलरली फॉर दिस 1 2 3 4, इसका इन्वर्स क्या होगा, इसका इन्वर्स होगा 4 3 2 1, बिकॉज 1 2 3 4 टाइम्स ऑफ 4 3 2 1, ये क्या हो जाएगा, आइडेंटिटी आएगा, आइडेंटिटी है ना ये। ओके, एज सिंपल एज दैट। नाउ वी हैव आइडेंटिटी परमुटेशन। आइडेंटिटी परमुटेशन क्या हो जाता है, सिंगल मैपिंग। सपोज वी हैव द एलिमेंट्स एज 1 2 3, 1 2 3, so 1 goes to 1, 2 goes to 2, 3 goes to 3. दिस इज आइडेंटिटी परमुटेशन. अब क्या है, टू साइकिल को क्या बोलते हैं, ट्रांसपोजिशन बोलते हैं. ठीक है, ट्रांसपोजिशन. आई जे इज ए ट्रांसपोजिशन, आई जे इज ए ट्रांसपोजिशन. इस मीन्स सपोज सिग्मा इज इक्वल टू आई जे इज ए ट्रांसपोजिशन. ये क्या करता है, आई को जे पे भेजता है और जे को आई पे भेजता है. डिकम्पोजिशन ऑफ साइकिल इनटू ट्रांसपोजिशन इज नॉट यूनिक. यूनिक नहीं है, किसी एक तरीके से नहीं लिखा जा सकता है. डिकम्पोजिशन जो हम कर रहे हैं ट्रांसपोजिशन में, किसी एक यूनिक तरीके से नहीं लिखा जा सकता है. और नंबर ऑफ ट्रांसपोजिशन आफ्टर डिकम्पोजिशन इज ऑल्सो नॉट यूनिक. ओके, तो ट्रांसपोजिशन को कैसे, ट्रांसपोजिशन में कैसे कन्वर्ट करते हैं, जैसे a1 a2 am-1 am ऐसा दिया हुआ है. ठीक है, इसको कैसे करोगे, तो फर्स्ट एलिमेंट और लास्ट एलिमेंट को ले लो. तो a1 am, देन फर्स्ट एलिमेंट और सेकेंड लास्ट, तो दिस इज a1 am-1 लाइक दिस. और लास्ट क्या होगा, a1 a2. ये सब क्या है, टू साइकिल है. दीज आर टू साइकिल. दिस इज ए ट्रांसपोजिशन, दिस इज ट्रांसपोजिशन, दिस इज ट्रांसपोजिशन. ठीक है, जैसे 1 3 2 है ना, तो कैसे लिखा है देखो, फर्स्ट 1 को लिया और 2 को लिया, 1 को 2 को लिया, देन 1 को और 3 को लिया, 1 और 3 को लिया, तो ये एक ट्रांसपोजिशन है. ये भी एक ट्रांसपोजिशन है. तो देखो इसमें क्या है, 1 3 2 को हमने ऐसे भी लिख दिया और ऐसे भी लिख दिया, तो यूनिक नहीं है ना. तो डिकम्पोजिशन इनटू ट्रांसपोजिशन इज नॉट यूनिक, फर्स्ट पॉइंट. दूसरा पॉइंट क्या है कि जो नंबर ऑफ ट्रांसपोजिशन हो रहा है ना, जैसे 1 4 3 2, इसको 3 नंबर ऑफ ट्रांसपोजिशन में ब्रेक किया गया है, और इसको क्या है 5 नंबर ऑफ ट्रांसपोजिशन में. तो द नंबर ऑफ ट्रांसपोजिशन यूनिक नहीं है, यहाँ पे 3 है, यहाँ पे 4 है. समझ में आ रहा है? ओके, so the point here is that ij is a transposition. So two cycle is known as transposition. Ij is a transposition. This means I sends. Okay, so transposition sends I to j and j to I. ट्रांसपोजिशन का ऑर्डर क्या है, 2 है. डिकम्पोजिशन ऑफ ए साइकिल इनटू ट्रांसपोजिशन इज नॉट यूनिक, मतलब जो डिकम्पोजिशन हो रहा है कोई यूनिक नहीं है. ओके, नंबर ऑफ ट्रांसपोजिशन जो हो रहा है, मतलब आफ्टर डिकम्पोजिशन द नंबर ऑफ ट्रांसपोजिशन दैट वी आर गेटिंग इज ऑल्सो नॉट यूनिक. ओके, so this is all about the properties of the permutation. Thank you.